We can't go for the entire population. We need to study the sample size, okay, from the selected random selection. Coming under the discrete random variable or discrete probability distribution. So any problem, any experiment without having an X series, so we cannot go further. In these two cases, we are trying to go for probability mass function. In the normal distribution, we are trying to go for probability density functions. Hello everyone, a warm welcome to one and all. I am Natesh, lecturer in commerce, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. We are in the Unit 3, Section 7, third semester BCom, probability distribution, and today my agenda, under probability distribution, binomial distribution. Today my focus on the binomial distribution. In the last session, I have discussed which is related to discrete random variable and continuous random variable. Under discrete random variable, there are four types: Bernoulli distribution and binomial distribution, Poisson distribution, and I for geometric distribution. So in today, under discrete random variable, binomial. Okay, so the binomial which is completely based on the Bernoulli. Okay, so moving forward, so here the frequency distribution, any probability or experiment when you try to conduct, okay, so we are trying to select two data which is a discrete and continuous data. So here which is advanced probability distribution, a frequency distribution is a useful way of summarizing variation in the observation of data. Observation of data means wherever when you are finding a observations like a frequency, okay, in the set of data, either it is a discrete group or ungrouped data. Group data, of course, we are able to identify there is a frequency. So if frequency distribution is prepared by listing all the possible outcome of on an experiment X. So that means actually 0 how many times repeated, 1 how many times is repeated. When you are taking in examples like a coin or two coin or two dice, okay, so the total outcomes, how many times which will be repeating, indicating the observation frequency of each possible outcome, because you need to identify the frequency. Okay, unless you are not identify the frequency, because based on the probability when you are trying to solve, okay, you need to select a experiment. Here the functions which is the probability theoretical distribution are also related to frequency distribution. The probability what we are trying to conduct, so using a binomial factors, binomial process. Okay, so far we have studied empirical observation experimental frequency distribution which is related to probability to approach. So we studied classification, empirical, and modern or axiomatic approach. So in which the actual data were collected. Without data, we cannot go for solving the problem. Okay, we need to find out informations are provided, classified and tabulated in the form of the frequency distribution, because the set of data we need to formulate, we need to go for classification, we need to go for summarizing. So normally such data are based on the sample study, because we can't go for the entire population. We need to study the sample size, okay, from the selected random selection. Okay, moving forward. So the statistical measures such as average, in the first two chapters you have well familiar with the average, which is a measure of central tendency, and dispersion, okay, and even the correlation. In the next chapters will be correlations related, are used to know about the features of the population, because any statistical which is completely based on the represented unit or population. So however, a more scientific way of drawing inference is nothing but your decisions making. So when you are trying to do for probability distribution, which will give you more better solution. Okay, so about the population character, because based on the characters you have studied in the different quantitative characters, qualitative characters, whatever which is related to the populations, is through the study of probability of distribution. Because any experiment which is related to conduct, of course we are trying to go for selection best decisions. So thus the frequency distributions are two types. One is actual frequency distribution. Actual frequency distribution, the set of data when the number of, for example, X and frequency. So 0 is repeated 2 times, 1 is repeated 2 times. So frequency which is observed frequency, actual frequency, which is based on the actual or real data obtained by survey, because the data collection which is based on the data, source of data, our primary source and secondary data. At the time of collecting a data, we are trying to go depend on the survey, interview. So like this, the survey and observation of experiment based on the experience. Okay, so based on the experience also we are trying to collect a data. Okay, second one, the probability distribution, which is based on the value of the variable which is distributed according to some of definite probability law, because when the value is completely based on the distribution, okay, which is keep on varied, experiment to experiment the value are varied, so we need to collect based on the definite probability, because here whatever it is possibility is there to collect the data, so using a definite probability law. Moving forward, so next one, the probability distribution which are not obtained by actual observation or experiment. The frequency distribution which are not obtained actual observation or experiment. See, when you are trying to conduct any experiment, so with the help of experiment only we are trying to go for observation. So here, but are mathematically deduce the certain assumption are called theoretical frequency distribution, because all the experiment we cannot go for final conclusion. So for that reason, there is no standard definition which is given to the probability. So when in case of experimental, when you are representing as a mathematical representation, also called expected or theoretical expected frequency distribution. In the last section, you know, which is related to the mathematical expectation and random variable. So since they are based on the probability of outcome, because whenever any experiment which is finally we are expecting a result or outcomes, so they are probability distribution. So here the theoretical frequency distributions are many types, but three of them are great important in this statistical analysis. So there are different types of distributions we are going to study. Okay, so here the majorly more area, certain area is normally which is using for binomial, Poisson and normal distribution. So out of this, the first two are which is coming under the discrete random variable. Okay, so discrete probability distribution, so which is studied in the last session, which is a discrete random variable. Okay, now the first two, binomial and Poisson, which is related to the discrete probability distribution, and the third one is a continuous random variable. Here in these two cases we are trying to go for probability mass function. In the normal distribution we are trying to go for probability density functions. Moving forward, so here the main in the today's session, which is main focus on the binomial distribution. So here the binomial distribution, binomial probability distribution is a widely used probability distribution, which is a few examples for identification of binomial, coin related, dice related. Okay, and so which is commonly the baby birth. In the next slide there is a few examples to understand the binomial distribution. So concern with the discrete random variable, which is main focus on the discrete random variable. Okay, so because the set of data which is there is no lower limit and upper limit, only the x series value and observations, and hence the discrete probability distribution. So for tossing a fair coin fixed number of time, because when the Bernoulli distribution we are taking a very limited sample, but binomial, so large samples we are taking n number of times. So when you are tossing a coin, so the result, so which is related to the binomial process. Okay, and the outcomes of such tosses can be represented by the binomial distribution. When a limited number of times when you are tossing, which is related to Bernoulli. When number of times are increased, now which is going for the binomial distribution. It is also called Bernoulli distribution, because the James Bernoulli is a person. Okay, so because it is associated with the name of the Swiss mathematician Jacob Bernoulli, okay, in the year of 1654, 1705, okay, so he is a mathematician. So binomial distribution is a probability distribution, so expressed in the probability of one set of dichotomous or two alternative P and Q. P is a success, Q is a failure. Now the total probability always which is equal to 1 only. So here in this case, when you're tossing a coin, when head appear, no doubt which is a success. When you are expecting head, unfortunately the tail is occurred, means which is related to failure. So here the binomial distribution, so have clearly specified which is coming under the discrete random variable or discrete probability distribution. So any problem, any experiment without having an X series, so we cannot go further. So here if X is a discrete random variable with the probability mass function, the probability mass function means, so using some parameters we are trying to solve the problem. So here P of X is nothing but your probability mass functions. Okay, NCX. Okay, N means the total outcomes. Okay, from the experiment, total outcome. For example, 2 coins if you take. Okay, the 2 coin, the total result will be either you are expecting head or tail or head one tail head. Okay, there are 4 outcomes are coming, which is coming under small letter n. Okay, from this. So when you are expecting, always expecting head means here 2 head you are expecting, here 0 you are getting, here 1 head, here head, 1 head. Now with the help of X series only, we are trying to go for frequency. Now tail, first one 0 and 1 is 2 times. 2 head is 1 time. So in this case, we are trying to go for depend on the frequency because number of repetition. So N is a total outcomes 4. Now C is a combination. X is a, you are selecting from the frequency or X series. Okay. So which is starting from the 0, 1 and 2. So like this. So NCX into P. P is nothing but your success. To the power of X. X means whichever you are writing. Like this, for example, P of the experiment which is starting from 0. So instead of X place, we are writing 0. Now, if you try to go for the 2 coins, no. So there are 4 outcomes. Okay, see, X you have considered for 0 and the probability in coin 1 by 2. Always the result is 1 by 2. To the power of X because you have written for X. X value 0. Again, failure value. Q is a failure value. Again, the probability also equal chances. Okay, 4 minus 0. Now, which is looking like A plus B format. So, which is a common value. So, here, where 0 is less than P less than 1. So, which is the total probability value. So, P of X, the probability of X event. So, X event, for example, 2 head is 1 event, 2 tail is 1 event, and 1 head, 1 tail is 1 event, and 1 tail, 1 head is 1 event. You need to set the event. So, now you got the value, for example, X is an X series is already we got the X series which is starting from 0, 1, 2 till N. So, if the number of coins are increasing, so the value also, the outcomes also will increase. So, here N stand for number of trial taken. Okay, because the total coin, 2 coin we consider, the total result will be 1 to 0, 1, 2. Okay, the total result what we are expecting, still the experiment. If you take for 2 dice, 36. So, which is starting from 1 to end with 36. So, here the P is a probability of success. And Q is a probability of failure. How? If you know the probability of success, easily you can calculate for the failure. So, because the total probability always 1. So, 1 minus the success, if you subtract, you are getting the failure value. Then, X is a binomial variate. Because you are trying to do the problem with the help of binomial distribution. So, now you need to consider for the binomial variate. And the distribution of X is called for binomial distribution. So, which is very simple. Moving forward. So, here the parameters of the binomial distribution or property of binomial distribution, what exactly you are able to identify with the help of probability mass function. See, once again I am writing probability mass functions. Mass function, the formula is simple. NCX to P to the power of X and Q to the power of N minus X. What and all you are identified here? N which is common, P is common, Q is common. Okay. So, here the distribution depend upon the value X. Either you are writing or you can take for X. Both are same. So, whichever the experiment which is identified with the help of experiment. So, N is a total numbers. So which are is a parameter? Yeah, x and n will be the parameters. Okay. So knowledge of P is a success truly define the probability of R. R since you can write like X also. And N is a number of total outcomes, is known as a definition of the problem. The probability of the happening of exactly R or X, okay, event in the N, the total trials, okay, so can be found out using the above stated binomial function, because the probability mass function you must remember what and all you can observe here commonly, okay. So in this case you can write R also or X you can write, so anyone. So incidentally, it may be stated that the value of P is a success determine the general appearance shape of the binomial distribution, because the parameters basis only the probability mass functions is completely depending. So the usage of generalizations are how you can use. So when P is a small, success is small. Okay, so say for example 0.1%, because which is always equal or greater than or equal to 0, because the probability which is always equal or greater than 0. Okay, so the binomial distribution is Q to the right, because the bell-shaped curve, what you are exactly Q to the right. When P is more than 0.5, because exactly when you are trying to go for 0.0 is located here, 0.5 and 0.5. So if it is 0.5, the distribution is Q towards the left side. Okay. So when P is a 0.5 exactly, which is equal, okay, so the binomial distribution is a symmetrical. Now exactly this one is a bell-shaped curve. Okay, equally which is a distributing either right side if it is going, either right side or left side it's going. Moving forward. So importance measures are parameters of the binomial distribution. So which is a 2-mark questions. Maybe you can expect. So the expected value of random variable E of x we are writing. Expected random variable. So in the question observation frequency is given. So with the help of observation frequency we need to find out for the expected frequency. So that means the mean of the random variable of binomial distribution is equal to, because in the probability mass function these are the parameters we have identified. So in this case the same NPQ, okay, the mean is nothing but NP in the binomial distribution. Okay, so EX is nothing but your arithmetic mean. In the last session I have explained. So NP is nothing but your mean of the random variable. Okay, so NPQ and the variance, NPQ and the variance equal to NPQ. See, NPQ is equal to X bar you can't say, which is related to the variance. So here the binomial mean X bar is always equal to the NP. Okay, variance which is related to NPQ. Okay, hence the standard deviation of binomial distribution equal to. So if you write like this, if you are writing inside the square root, so NPQ, which is nothing but your standard deviation. Okay, so these are the parameter. So here binomial distribution X bar is equal to NP. Okay, so standard deviation inside the root NPQ and variance which is NPQ. Moving forward. So here the binomial distribution example, sometime if they won't specify in the questions which is related to the binomial distribution or Poisson distribution, with the help of examples only we can identify which is related to binomial or Poisson. So here a few examples which is related to binomial distribution. The first one, number of heads when 5 coins are tossed. If one coin means which is going for the Bernoulli. So 5 coins are tossing. And one more, getting odd numbers when 2 dice are rolled. Okay, because number of 2 dice means the sample will increase till 36. So number of defective item in the sample of 10 item, because the 10 items, so the number is increasing. So defective items identified. And number of male children in the family of 2 children, which is related to binomial distribution. And the fifth example, number of bombs hitting a target among 3 bombs which are aimed at it. Okay, that is also one example for binomial. 6th one, number of defective article in the random of sample 6 article drawn from a manufacturing lot. So there are too many, the manufacturing lot you are choosing. Okay, so the number of seeds germinating among 10 seeds which were sown. Okay, so which is also related to binomial distribution examples. So here, fitting a binomial distribution, which is 100% you can expect for a long question. Okay, how to fit? So when you try to fit the probability distribution using a binomial distribution, the parameters you know, n and p. N is a total outcome, p is a success, are 2 parameters of binomial distribution. So these are the common parameters in the binomial distribution. The value of n and p determine the distribution completely, because under probability mass functions only we are identified n and p, and even q also. To fit the binomial distribution, the value of n and p are found. You need to identify the n value and p value. Okay, so in the binomial distribution we need to identify. Okay, here then the theoretical probability and corresponding theoretical frequency are obtained. So because whenever you are conducting an experiment, the number of observation what you are identified in the questions. Okay, fitting a binomial distribution in practice for observation of data. For example, the frequency which is clearly specified in the question. So we need to consider the observation frequency which is given in the question. So we may examine if the value follow the binomial distribution. This is called fitting a binomial distribution for given data, because any experimental with the help of whatever I have explained which is related to examples basis. So we need to identify the observation frequency. We shall consider the procedure to fitting a binomial distribution when conditions are admissible. So the binomial distribution has the 2 parameters, namely n and p. N and p is the parameters. Okay, these are the 2 values determine the distribution completely. So completely binomial distribution with the help of n and p only we need to identify. So to fit the binomial distribution, the value p are found. You need to identify the value of a p. So out, since n is given the data, because the number of the total outcomes are given in this question, so we need to identify. Then the theoretical probability are written. Then only we can write the theoretical format. Okay, when you are solving a problem, you will get more clarity. So the theoretical frequency can be obtained by multiplying the probability by the frequency n, unless we are not getting the x value. For example, x bar value is np is, which is nothing but, okay, so np, if you try to extend using the value, the formula is same to find out the mean value. So if you know the value, here the small letter n is which is related to the value for the total outcome, n is the total frequency moving forward. So the steps to be followed when you are fitting a binomial distribution, the first step is to calculate the x bar value. X bar is nothing but np in the binomial distribution, always you must remember. So if you try to extend, because in the question x value is given and even the frequency also given. If you multiply fx value divided by n, so which is giving for the x bar value. Okay, so where x is a observed value in the experiment, f is a frequency which is given in the questions. N is the total frequency which is common. We already measure of central tendency. You got more clarity for calculating the arithmetic mean. So second step, once you get the x bar value, equate the observation mean value to the theoretical mean of the binomial distribution. Equate means what? You need to simplify. Okay, so n value, since n is given in the data, the data, unless the x value, for example, in the 2 coin 0, 1, 2, so which are the x value, no, because you are observed always for it only. P can be easily found out, and also Q also. If you know the P value, you can calculate. So here, for example, in this case, if you try to go for coin, N also value is given. For example, 4 N value, P you don't know the value, sigma X value something like 100 you assume, divided by 20 is the frequency total, any example. So if you try to go for cross multiplication, so easily you can find out the P value. Okay, so like this, when we are solving the problem, you can get more clarity. So easily you can get the value for Q. The third step, find the theoretical probability x of 0, which is starting from the 0. The experiment will start from 0 using the binomial probability mass function. The formula is very important. N is a total. NCx into P of x into Q n minus x. So here x is nothing but your experimental result. For example, the experimental will always starting from the 0. So we'll consider for x is equal to 0. So when you are written small letter, which is a represented outcomes, okay. So P of x is equal to 0. NC x plus we are just writing 0, 0. Okay, moving forward. And the fourth step, find the theoretical frequency x of 0. So E of x, okay, whatever you calculated in the third step, the probability mass function, if you try to multiply with the respected n, so the frequency total, then you are getting a theoretical expected frequency. Theoretical frequency, or you can write expected frequency. Ex, which is first experiment, which is starting from 0, because we already calculated probability mass function using a 0. Now we are multiplying n, okay, respected that frequency total. If you multiply, then you are getting for 0 value for expected frequency, first value expected frequency. Now once you completed, now fifth step, round off the theoretical frequency, whatever your expected frequency, for example 0.001 you are getting, round off you want to make it just a correct figure, all numbers, so that the total frequency always getting frequency, observation frequency, which is given in the question. So you need to find out the expected frequency. Expected frequency and observation frequency value are always same. The sixth step, write both the observation and theoretical frequency in the table so that the comparison can be easily. For example, in the observation frequency, the frequency total we got a 64. Okay, after expected frequency also we calculated. The frequency total we are getting 64. So both are easily we can compare. Keep on watch for next section. Thank you.